My friends, you're going to understand stoichiometry and stoichiometry problems like nobody's business. I'm telling you, this is going to be your jam after this video. And there's 3 easy steps. This isn't a shortcut. This has been known for decades. It's in the textbooks, but maybe you don't really understand it, or maybe you haven't been taught this stuff very well at all. Well, today's the day. This is going to be your jam. You're going to rock it, no cap. All right, so we're going to learn these 3 steps that I have here. So let's start. What mass in kilograms of NH3 is required to produce 1.25 times 10 to the 4 grams of N2H4? And we have this chemical equation here. Now, you know this is stoichiometry. We know we have to apply these 3 steps on the right. We have to apply these steps to this problem because this is what we have. We have a balanced chemical equation. We have some information about one of these compounds. So in this case, N2H4. So N2H4 is here. We know there's 1.25 times 10 to the 4 grams. So we know something about this. And we need to know something about another compound. So in this case, it's NH3. And we want to know the mass of NH3. So whenever you have this balanced equation and you're given information about one of the compounds, you want to know something about the other compound. That's this 3-step process here. It's stoichiometry. You can rock it. So step number 1, we want to calculate how many moles of the given there are. Now, what's our given? Well, the given is N2H4 because that's what we know, how much we have of it. So that's our step 1. So we're going to go for 1.25 times 10 to the 4 grams of N2H4. And you don't just want to put grams, all right? I know it's like a lot of us do this, but you want to say what it's grams of. Super important. N2H4. It takes a couple extra seconds. It'll save you marks. So N2H4, and we want to convert to moles. So to do that, we always multiply it by a fraction. Okay. We want grams to cancel out, so we need grams in the denominator of N2H4, and we want moles in the numerator because that's what we're solving for. Moles. Moles of N2H4. This is N2H4. Now, we need to know how many grams in 1 mole. This is a molar mass, and I'm just going to give you the molar mass because I'm assuming you know how to calculate the molar mass. If not, let me know. I can make a video on it. But the molar mass of N2H4 using the periodic table is 32.045 grams. Oh, actually, I'll show you. So if you look at the periodic table, this I got from ptable.com. It's super awesome. And let me hover over nitrogen here. So see nitrogen. So this is what you'll see in the periodic table. This top number is the atomic number, which is how many protons there are. This bottom number here is the mass. So 14.007 is how many grams nitrogen weighs in 1 mole of nitrogen. So we add this to, there's 2 nitrogens, add this to the 4 hydrogens, and we have 32.045 grams per mole. It's the molar mass of hydrazine there. Okay, so we will calculate this on our calculator. And 1.25 times 10 to the power of 4 divided by 32.045, 390.08. So 390.08. And the units are grams cancel out, so we're in moles. Moles of N2H4. Now, step 2, we use the answer from the previous step. So 390.08 moles of N2H4, and we convert to moles of our desired. So to do that, we need to use the balanced equation here. And on this equation, this is our given, this is our desired. So this is what we want to know something about. So this is our desired here, NH3. And there's no number here, which means that there's a 1. Well, 2 moles of NH3 react to produce 1 mole of N2H4 is the ratio. So there's a 2-to-1 mole ratio. So we set that up. We can convert from N2H4 here by basically doubling it. If we have this many moles of N2H4, we need twice as many moles of NH3. And we set this up by using a simple fraction just like what we did before. So we set up a fraction, and we want moles of N2H4 to cancel out. And when we set up these fractions, always put in the units first. So moles of N2H4, and we want moles of NH3. And see how I did the units first? Now, because of that, I know that N2H4 cancels, moles of N2H4, and we're going to get, our answer is going to be in moles of NH3, which is what we want. So always do the units first. Now, there's 2 moles of NH3 for every 1 mole of N2H5. So we'll multiply this by 2. I could probably do this in my head, 780.16, I believe, moles of NH3. NH3. Okay, so that's step 2. And lastly, step 3, we want the units of our desired. So units is whatever we're trying to solve for. In this case, mass in kilograms. Well, that's annoying. Kilograms. Anyways, we want to get the mass. So we're going to go use the answer from the previous step, moles, and then we want to go from moles to kilograms eventually. Now, we can't go to kilograms directly, of course, because we need to use the molar mass. So we'll go to grams first. So we'll take 780.16 moles of NH3. And using the periodic table, the molar mass of NH3 is 17.031. But we won't put that in first. First, we'll put in the units because we want moles to cancel out. So we'll put moles of NH3 here. And we want grams of NH3. Now that we know that our units match, we safely know that we're going to put the grams up here. And based on the periodic table, the molar mass of NH3 is 17.031 grams for every 1 mole. Okay, so we'll put that in our trusty calculator. 780.16 times... Oh, we're not done yet, right? Because we're in grams. Actually, before we do it, just to save some time, this gives us grams, and we want kilograms. So we got to do another conversion here. We want grams to cancel out. So we put in the denominator. We want kilograms. And for every 1 kilogram, that weighs 1,000 grams. So grams cancel out there. Okay. Sweet. Awesome. So 17.031 divided by 1,000 is 13.29. So 13, whoops, make it white. 13.29 consistent kilograms of NH3. And for full marks, you got to go back to the question and look at significant figures. We have 3 sig figs here. Now, these numbers only have 1 digit, right? But they're exact numbers, so they don't count towards significant figures. So we have 3 sig figs. So the answer is 13.3 kilograms of NH3. Cool. So this problem is commonly screwed up on, messed up on exams, midterms, final exams. You can still use these 3 steps here, and I'm going to show you how it works. It's awesome. It works. Let's get into it. Okay, so 10.00 milliliters sample of calcium hydroxide. I'm going to put this in here just so we work through it as we read it. Is titrated with 23.55 mils of this concentration HCl. So HCl is here, and we have 23.55 milliliters that we used of it, and 0.01150 molar. And capital M means molarity, which again is a hidden unit. It means moles for every 1 liter. And I would put that in for every moles for 1 liter. Okay, and what's our question mark here? What is the concentration of this? So the concentration of this is our question mark. So this is our desired, and units are in concentration, molarity. Concentration is not a unit. Concentrations in molarity, moles over liters. So step 1, we want to calculate the moles of our given here. And it's always, by a rule of thumb, you want to start with the number that only has 1 unit. So 23.55 milliliters. That's because this one, if you have more than 1 unit in a number, like this number has more than 1 unit, moles over liters, it's good to convert. It's a good converting factor that we can use. Okay, so we want to convert to moles, but this is in moles over liters, not milliliters. So first we need to get to liters. So we want liters. We want to cancel out milliliters. Now that we have the units that work out, we know that in 1 liter there's 1,000 milliliters. Or if not, you know now. Now that we're in liters, we can go to moles. So we'll use this here, moles over liters. We want liters to cancel, so we'll put liters down here, moles up here, And for every 1 liter, there are 0.0150 moles. Liters cancel out, and we're left in moles. Now I'm going to do the second step here, just to save on time and space. We want to, second step, get the moles of our desired. And there's a 1 to 2 ratio. See, there's no number here, so that means there's a 1. So we'll write that out. Now we'll cancel this out. And look what happened. I just put moles and liters. I didn't say what compound this is for. Terry. This is for our givens. So this is HCl, moles of HCl. This is all for HCl here. And this is important because we want to cancel out moles of HCl, and we want moles of CaOH2. CaOH2. And for every 1 mole of OH2 that reacts, it needs to react with 2 moles of HCl. Okay, now step 3 would be to get to units. But units here, concentration, it actually has 2 units. It's a molarity. So we're going to just solve this first and then kind of deal with the units after that. So 23.55 divided by 1,000 times 0.015 divided by 2 is 1.766 times 10 to the negative 4. So 1.766 times 10 to the negative 4. And our units, what are we left with? Moles of our calcium hydroxide, moles of CaOH2. Now, to get our units, we can do another conversion factor, or you can just use the formula C equals N over V to get the concentration. We know that there's this many moles, 1.766 times 10 to the negative 4 moles. And what's the volume in this many moles? Well, it's a 10 ml sample. So this should say what is the original concentration of calcium hydroxide. Anyways, in 10 mils. So there's this many moles in 10 mils. Again, we need to convert milliliters to liters by dividing by 1,000. So we'll just say 10.00 times 10 to the negative 3 liters. Hope that's okay. Let me know if that doesn't make sense. And we could do this in our head. So this is really, this number is 10 to the negative 2. And then we can flip this, when we do this divided by this, anyways, the exponent becomes positive because we flip it over. Anyways, you can plug it in your calculator. 1.766 times 10 to the negative 2 was 0.0. How many sig figs? Oh, moles per liter. How many sig figs do we have? We have 4 here, only 3 here. So our answer should have 3 sig figs. So 177 moles per liter of calcium hydroxide, CaOH2. All right, y'all, I hope you enjoyed that. I hope these 3 steps made a lot of sense. I hope it was crystal clear for you. And you just got to keep practicing these. So you might not do well if you just stare at a video and go through it and write the exam. Maybe you will. Maybe that you can remember, that sort of thing. But you're really going to do the best when you work through these problems. But now you know how to use it. You have these tools in your tool belt. You can do it. You can own this exam. I know you can. Good luck. I'll see you in the next video. Cheers.